Hello, everyone. In this video, we're going to look at some examples of how to compute confidence intervals for proportions. So before we get started, I just want to summarize the main steps that we need to take when computing a confidence interval. So our first step is just to ensure that we can use the standard error formula for the proportion that we found in the previous video. So recall those conditions are that we have independence of our data, we have randomization of our sample, and we have a large enough sample size. And we'll look at that in more detail when we work through this example. After that, we're going to construct our confidence interval. And so for that, we need to first find or compute p hat, that's the sample proportion. Then from there, we also need to find the z star value that we're going to use depending on our confidence level. And then we compute that standard error. So that's p hat, q hat over n. After we've constructed the interval, then usually we draw our conclusion and interpret. Interpret, we'll say confidence interval. All right, so now let's look at this example 5. So for example 5, we are told that a poll asks 166 adults in the US whether they were baseball fans. Of these 166 people, 46% said that they were. So part A says construct a 99% confidence interval for the true proportion of US adults that are baseball fans, and then interpret. So before rushing to make any calculations, let's just first interpret all of the information that we are being given. So first of all, we're told that this poll asks 166 adults. So that tells us our sample size is 166, or n is 166. Then we were told of them, 46% said that they were baseball fans. So this 46% tells us the proportion of our sample that are baseball fans. So that is going to be our p hat. So from this, we can determine, well, how many people in our sample are baseball fans? So how many successes do we have? Well, that's just our total sample size times that percentage that are baseball fans. So we take 166 times 0.46 to get us how many people were baseball fans. So we can do that calculation here on our calculator. 166 times 0.46. So about 76. This percentage here is probably rounded. Well, is rounded because we can't have a part of a person. So we have 76 successes in this case. Okay, so now let's look at part A, where we're told to construct a 99% confidence interval for the true proportion of US adults that are baseball fans. So the proportion that we want to try to estimate with our interval is this proportion here of US adults that are baseball fans. So this is the P that we want to estimate. Not a p hat, but P, because we're looking at a population proportion. So this 99% tells us what we're going to use for our z star value. So to find z star, we can look back at the table that we generated in the previous video. Looking at a 99% confidence interval, our z star is going to be 2.5758. So we can copy that down on the next page. So 99% confidence interval tells us that our z star is going to be 2.5758. So I encourage you, when you see questions like this, to always pause and just take inventory of all of the information you're given. This will also help you to make sense of the context of the problem and then to see a path forward. Okay, so now let's go through our steps, which means that we first need to check that the conditions are met. So let's do that together. So step number 1, check conditions. So we need independence, randomization, so for these two conditions, we're not told how we are collecting the sample. So because we want to have a meaningful example here, we're going to assume that, yes, this is true, that our sample was taken such that our collection was independent and random. But we can check successes and failure. That is, do we have enough people who are successes, meaning are baseball fans, and do we have enough people who are failures, which means they aren't baseball fans? So that means we want to take 166 times the percentage who were baseball fans, 0.46. So we computed that's about 76, which is larger than 10. And similarly, if we then look at the percentage, or the number rather, of people who are not baseball fans, that would be n times q, we're going to get the remaining people. So about 90, which is also larger than 10. So check, check as well. Okay, excellent. So that means we can use the formulas that we found in a previous video. Okay, so now let's take a look at constructing that confidence interval. So fortunately for us, we've already found all of the information we need. Recall that confidence interval will look like p hat plus or minus z star times the square root of p hat q hat over n. So we can just fill in all of the numbers that we have. So for us, p hat is 0.46 plus or minus z star is 2.5758 times the square root of p hat is 0.46, q hat is 0.54. And just a side note here, p hat, or rather q hat, you might be asking, how did we get this number? Q hat is just equal to 1 minus 46, which is 0.54. So the more of these you do, the more comfortable you will be with making computations like this, where we just take 1 minus our p hat. Okay, so let's continue working out this formula. So now then we would divide by 166. All right, so now we just need to consult our calculator here to carry out these computations. So we'll go over to our calculator. So what I'm going to do is just compute that margin of error. So I'm going to compute 2.5758 times, and I'm going to use a lot of parentheses because I want my calculator to know the order in which I want to multiply things out. So times parentheses, square root of, and I'm going to do another parentheses here because I want all of this fraction that I'm going to input here in the radical. So times 0.46. And actually, you know what? I'm just going to back up and do one more set of parentheses because I want to first multiply my numerator. So 0.46 times 0.54. Then I'm going to get out of that parenthesis and divide by my sample size, 166. And then get out of that parenthesis and get out of that one. All right, so what we're getting here is 0.0996. And we see that on the bottom right of the screen there. So I'm going to round up to the nearest 4 decimal places. So I can write this as 0.46 plus or minus 0.00996. All right, so now I can consult my calculator to get my lower and upper bound. So my lower bound will be 0.46 minus 0.0096. So that will be oops, so good catch, everyone. I had an extra zero though, 0.0996. So my lower bound is going to be 0.3604. So we'll copy that down. And my upper bound is going to be the same thing, but I'm going to add now that standard error. So we're going to add. We get 0.5596. 0.5596. So here is our confidence interval. All right, so our final step is to interpret our confidence interval. So 3, conclusion. So recall, our confidence interval tells us the interval at which we are, in this case, 99% confident to find P, to find our true population proportion. So to set that up, we would say we are, in this case, 99% confident that the proportion of US adults who are baseball fans we'll zoom in here, is between 36.04% and 55.96%. So just to summarize how we're finding that, we are 99% confident. So 99 is coming from our confidence level, that the proportion of all US adults who are baseball fans, so that's the population proportion, is in our confidence interval. Awesome. All right, so now let's take a look at part B. So part B is going to be similar, but in this case, we want to construct a confidence interval with a confidence level of 88%. So how is this problem going to be different than the one that we just looked at? Well, now rather than using Z star as 2.5758, we want to use the Z star associated to a 80% confidence interval. So let's take a look at what that would mean. So we can go back to our reference page from our previous video, look for our 80% confidence level. Our Z star would be 1.2816. So we're going to copy that down on the next page. So here for us, Z star is going to be equal to 1.2816. So now I want to go through those same steps that we just carried out for part A. So step number 1 is check conditions. So has anything changed here? Well, we still have the same sample, so we're going to still assume that we have independence and randomization. And then do we have a different number of successes or failures? Nope, because we still have the same p hat and we still have the same sample size. So we're not changing anything with our sample itself. We're just changing how we're going to compute that confidence interval. So when we look at that formula for computing the confidence interval, we're only changing this Z star. So everything else remains the same, which means we have the same number of successes and failures. Okay, so that makes this easy. We can just say same. Okay, and there we have our conditions checked. So now 2 is to compute the confidence interval. So recall, that's just going to look like, we start with our p hat plus or minus Z star times the square root of p hat q hat over n. So for us, again, it's going to be all very similar, but now we're just going to put in our 1.2816 for Z star. So we have 0.46 plus or minus 1.2816 times the square root of p hat, so 0.46 times 0.54, all over 166. So take a moment and pause the video and work out this standard error computation on your own calculator, and then continue watching and we'll check together. So when you put it into your calculator, you should be getting for the standard error, if we round to 4 decimal places, 0.0496. So we're going to add and subtract that to 0.46. So nice work if you got that. If not, please take a moment to pause the video and recheck your work. It might just be that you have a parenthesis in the wrong place, or maybe your calculator isn't taking the square root of the entire fraction that you want. All right, and when you're ready, pause the video again and compute that lower and upper bound. And you should be getting lower bound 0.4104 and upper bound 0.5096. All right, and lastly, step 3 is this: we need to write our conclusion, which is what we're going to do to interpret our confidence interval. So take a look at the conclusion that we did in the previous part of this example and see if you can replicate that conclusion here. All right, so the only thing we need to change from our previous conclusion is now we're 80% confident, still regarding the proportion of US adults who are baseball fans, but now we're just having a different interval in which we are confident to find that proportion. So we can write it out. We are now 80% confident that the proportion of US adults who are baseball fans is between 41.04% and 50.96%. Awesome, great work. So now we're going to look at this final box on our page here, where we're looking at certainty versus precision. So we have two statements here. First statement says, what happens to the size of the confidence interval the more certain we are? That is the higher confidence level. What happens to the size of the confidence interval the less certain we are, or the lower confidence level? Well, let's take a look at the two confidence intervals that we computed in this problem. So if we have a number line here where we're going to plot our confidence intervals, so here's our p hat at 0.46, then our first confidence interval goes from 0.36 about to 0.56. So if we have some tick marks here, maybe we'll do tick marks by 10. So this is 0.56. This is 0.36. Our first confidence interval goes from 36 to 56. So this was at 99% confident. Our second confidence interval for looking at 80% confident went from 41 to 51. So what happens to the width of our confidence interval here? Well, the confidence interval associated to our confidence level that was less confident is smaller. The confidence interval associated to the confidence where we are more confident is larger. So let's write that down and then maybe look at a couple other ways to think about it. So the first statement, what happens to the size of the confidence interval the more certain we are? So that is when we were 99% certain, we have a larger confidence interval. So that interval includes more possibilities of proportions. And we have this wider net that goes on. So we can also say it's wider. versus a confidence interval in which our confidence is less certain, so 80% certain, so less likely to happen, we get a smaller confidence interval. So our interval is more narrow. So we can also make sense of why this would happen by looking at a normal curve. So if we look at a standard normal curve, and if we look at where we'd expect to find 99% of the data, well, we'd be looking at most of the area underneath the curve. So we have a wider range here, or our values for our cutoffs give us a larger range. Versus if we only looked at where 80% of the data is, or something smaller, say 80% here, then our range of possible values is smaller. So that's another way of looking at what happens with the behavior of our confidence interval when we look at different levels of certainty.